After years of lively debate, it now seems the planet really is warming. The 3 hottest years on record have all happened in the past 7 years, and the area of global landmass suffering drought has more than doubled in 30 years. In Australia, the world's driest continent, decreasing rainfall and the chance of another El Niño are heightening fears the current devastating drought will worsen and put further pressure on city water reserves, which are already at near record lows.
Water, water everywhere, but not a drop to drink. It's a well-worn cliche, but it's a lot closer to the truth than you might think. It's predicted that by 2025, demand for fresh water will exceed supply by more than 50%, leaving 1/3 of the world's population without ready access to fresh water. But we don't call ourselves the blue planet for nothing. Our vast expanses of sea may well be our saviour. Back in 1988 on Beyond 2000, Simon Reeve introduced you to the world's biggest desalination plant in Saudi Arabia, where water was 4 times the cost of oil.
You're looking at the 40 desalination units, or evaporators, and it's when you get down to ground level that you begin to appreciate the size and the vastness of it all. They stretch for about 2 kilometres or 1.5 miles into the distance behind me, and without them, the city of Riyadh would virtually run dry.
There are now hundreds of plants like this in the Middle East, all of them enormously expensive to run. That's because they use a process called reverse osmosis, where huge amounts of energy are needed to pump seawater through fine membranes which filter out all the dissolved salts. But as you're about to see, a simple invention has revolutionised desalination, and those high operating costs are no longer a major problem. Los Angeles was built on the edge of a desert. There's plenty of salt water here in the Pacific, but almost no fresh water for a city of 10 million people. It's mostly pumped in from the east and the north. But Californian water authorities are looking at a different solution. The desalination of ocean water has now become a viable option, and that's thanks mostly to a remarkable device called the pressure exchanger. Incredible as it may seem, this rather plain-looking ceramic cylinder is changing the way the world desalinates water. So much so that all the arguments against desalination, most of them involving high energy costs, are being made redundant. While modern desalination plants are far more efficient than they were 20 years ago, they still use a whole lot of energy, most of which is wasted. On average, it takes 3 glasses of seawater to produce just 1 glass of drinking water. But you're still paying for the energy that it takes to process all 3. And that, ladies and gentlemen, has been desalination's Achilles heel. Despite their best efforts, scientists have not been able to radically improve that production ratio of seawater to drinking water. So they began investigating ways of harnessing the pressure energy of the reject seawater and using it to help power the whole operation. Californian company Energy Recovery Incorporated finally cracked the problem with a device called the PX pressure exchanger, which cut energy costs by a massive 60%.
So what the pressure exchanger does is it recovers the energy in that waste stream at almost 100% efficiency. It operates at 97% efficiency, which in engineering terms is extremely efficient.
John McHarg heads up the Affordable Desalination Collaboration, a US Navy joint project with the Bureau of Reclamation. For more than a year now, they've been testing and evaluating the latest desalination technologies, including the pressure exchanger.
With old desalination systems, you used to have to pump 100 gallons a minute to get 40. With the new desalination systems and this pressure exchanger technology, you pump 40 gallons a minute and you get 40 gallons a minute. It's amazing.
Yes, it really is that amazing. Just a ceramic cylinder capped at either end by fixed propeller-like end ducts and all precision fitted inside a tubular housing. When operating, one side of the propeller duct is open to the high-pressure wastewater stream, forcing the cylinder to rotate. On the other side of the cylinder, the second propeller duct is simultaneously exposed to the lower pressure seawater stream. So with each rotation, The pressure energy of the wastewater hits hard up against the seawater and, like a liquid piston, fires the seawater at higher pressure towards the membrane filters where desalination occurs.
It's very much like an old-style machine gun. They called them Gatling guns, and you saw them in the old Western movies where the guy's rotating the barrel, and the barrel's going da-da-da-da-da-da-da-da. So what happens is this pressure exchanger is almost identical in that it fires bullets on one side and rotates around and gets recharged with a new cartridge or a new water on the other side, then crosses over and fires again, and it's just going around continuously doing that.
So, by harnessing the energy pressure in the waste seawater and recycling it to help run the system, the pressure exchanger is effectively cutting running costs by more than half. And that's great news for cities like Los Angeles. As LA pays big money to pipe in 20 million gallons of water a day from the Colorado River, it's now looking seriously at this new cost-effective desalination process. The pressure exchanger has been retrofitted to several small plants around the city, all of them now producing fresh water for an average of 65 cents per cubic metre, cheaper than the maximum for dams and rivers of 67 cents per cubic metre. A far cry from the desalination plants of 25 years ago, which cost $2.43 per cubic metre. Every day, the need for fresh water is challenging nature's capacity to produce it. So what you're looking at here could be one of the most significant engineering breakthroughs you'll see in your lifetime. And that, I think, deserves a toast. Bottoms up. Nice.
Case of all things is notion of modern, efficient transport.
On first glance, it looks like a normal bus. But if you take a look in the driver's seat, you'll notice the big difference. The green mascot.
Anna Choi discovered they're not only quite smooth and efficient, they're also driverless. They run on a concrete track at regular intervals. They talk to each other and use magnets to keep separation between the buses. Can you imagine these working in a big city? Short answer, no. The front one stops to pick up and drop off. All the others have to queue up behind. Too slow and cumbersome. And most people would prefer to catch a cab. But imagine a scaled-down version of the system. Mini driverless electric cars. According to its inventor, this is the future of public transport. And it's all about to happen at the world's busiest airport. And just take a look around. Thousands upon thousands of people pass through here every day. And just like me, they're all on the move. A staggering 67 million passengers pass through Heathrow annually. Now that's more than the entire population of the UK. And they all need quick ground transport to get to and from terminals. So transport within the airport is a very big deal. After all, these places are like small cities. The challenge is to find a system that's more efficient than a mess of buses and trains and taxis. Well, the future is almost here, and right now, it's doing the rounds in a Welsh pasture. Meet Urban Light Transport, Ultra for short. A driverless, low-pollution, low-cost mass transit vehicle.
Right, they look really futuristic. It's like something out of the Jetsons.
Now, admittedly, one Ultra trundling around a Cardiff Bay test track does not solve a city's transport problems. But this is just to test the idea. And the idea is simple. Small cabs, which can stop at small stations, and the other cabs with other passengers pass right on by to other destinations. No stopping of traffic flow, and you're not at the mercy of other passengers getting on and off the bus. Professor Martin Lawson, CEO of the company behind Ultra, believes that when it comes to mass transport, bigger isn't always better.
It's one of the funny things that everybody believes that public transport, you have to have large vehicles. Well, the fact is, if you do it with small vehicles, it's much more efficient. And if you actually do the numbers, bus, for example, just goes by. It's got 50 seats. It only comes by every 5 minutes if you're doing well. That's only priced 600 seats an hour. Now, we've only got 4 seats, but we come by every 3 seconds. Now, if we work the number out, that's 4,800 seats an hour.
Ultra is not just earmarked for Heathrow. Cardiff City is also very keen on the plan.
We reckon we can put the system, the first system we put in will take about 5 million passengers a year. And those 5 million passengers, that bring 2 million passengers a year more onto the buses and trains.
Under the Cardiff plan, there would be up to 100 pods on fixed tracks servicing the most congested area of the inner city, providing a 60% faster trip with waiting times measured in seconds rather than minutes. Check this out. This is the guideway. It's not that wide, really. It's only about just under 2 metres. Doesn't take up much space at all, whereas a bus lane is probably twice that wide, out to about here. The Ultra's central computer system controls up to 100 vehicles at a time. Track layout places stations on off-ramp lines, so there's no impediment to flow. After drop-off or pick-up, the computer decides when to send the Ultra back into the main flow of traffic. I'm Ultra Chief Engineer Doug Robertson's mocked-up passenger for the day. Welcome. Doug, it's just brilliant. A really wonderful design.
Magic.
What do you think, mate?
Well, it really is quite futuristic.
How do I start? How do I get on?
Well, basically, the first thing you do is swipe a card, a smart card, against the reader.
The cost of a ticket is expected to be half that of a bus or train, thanks to cheaper setup and running costs. Okay, so say I wanted to go to
Terminal 1.
Terminal 1.
Okay.
Let's have a little chat to me. Confirm.
Your destination is Terminal 1.
That's correct.
And then the doors will open. And basically, in you go. Yep.
See you later. And we're off.
We're off. Yep.
Fantastic. Oh, this is just brilliant. There's room for 4 passengers and their bags. Very spacious in here, Doug.
It is, yeah. You can get 6 suitcases in between your knees.
Out we go. Doug and the other engineer boffins have solved one of the big problems with electric-powered vehicles: stopping batteries running out of juice. So every UltraPod starts its day with a battery charge that'll take it 15 kilometres. But how do you keep those batteries topped up? Imagine I'm an UltraPod. I've got my 4 people on board. I come up to my stop, they get off. I'm here for about 40 seconds. I've got 2 terminals that are touching a battery charger down here and topping my batteries up. I can run all day. If they get the green light, Martin thinks they could have the Ultra system up and running at Heathrow or here in Cardiff in about 6 to 9 months. Phenomenal. I'll probably still be here waiting for the bus.